Hello, my name is Brian Buckley, and this is my walkthrough for Physics 2212 Lab 2 Lines of Charge. This lab is a continuation of our first lab on charge tapes. Just a quick recap, the goal of the lab is to determine the approximate excess charge on a piece of Scotch tape, and the method to go about doing this is to find the sign of the charge on a piece of Scotch tape by comparing it to an item with a known sign charge, and we did this through the pen test. From there, we would measure the magnitude of the repulsion force between the two pieces of charge tape by balancing it with the gravitational force. The difference between Lab 2 and Lab 1 is in Lab 1, we treated the tape as one singular point charge, whereas in Lab 2, we are now treating the tape as a series of line charges. Some important laws and formulas that are used throughout this experiment in our calculations is Coulomb's law, the idea that like charges repel while opposite charges attract, as well as Newton's second law, the idea that mass is directly proportional to the force of the charge. This is useful in finding the force of the charge between the two pieces of tape because we can use the tape's mass as well as the acceleration due to gravity to find the gravitational force. And from there, because the pieces of tape are in equilibrium perfectly hovering above the ground, we know that the force due to the electric field is the opposite of the force due to the force due to gravity. Some underlying assumptions that go into this experiment is to treat the tape as though it were a series of line charges rather than the one point charge as stated earlier and as we did in Lab 1. And we would also assume that the charge is equally distributed along the entire length of the tape, although there are likely some very slight differences in the charge that are negligible in our calculations. We would also assume that each U-tape has about the same amount of charge, and we also assume that the force due to gravity and the electric field are the only forces acting upon the tape, ignoring air resistance. Although there is probably some air resistance, the difference is also negligible for our purposes. Here's my glow script code. The beginning part of it and the setup of the constants is pretty much identical to that of Lab 1. And the difference here is now, rather than calculating it as one single point charge, we divide the tape into multiple pieces, aka the line charges, and we then iterate through each piece to calculate the field before summing up each individual calculation to determine the total field on the tape. Here's the comparison of the model output from Lab 1 and Lab 2, and as stated and as we can see, on the left side, it only has one arrow to determine the one calculation of the magnitude of the charge, or of the force of the charge coming off the tape, whereas on the right is the model output from Lab 2, where it shows multiple arrows pointing in the upward direction to represent the multiple line charges that were calculated. And also, I would like to note the similarity in the charge of the tape calculated in each Lab 1 and Lab 2, where in Lab 1, the charge of the tape was found to be 1.166 repeating times 10 to the negative 9th coulombs, and Lab 2, where it is a very similar number of 1.16726 times 10 to the negative 9th coulombs. And some additional questions that we were asked to consider at the end of this lab is, what if we had modeled for each of the tapes as a single point charge, like in the previous lab, compare the estimate and to produce a point charge model. As I stated in the previous slide, they are very similar calculations between both labs, but why do they slightly differ in number, and which one is more likely to be closer to the real charge? These estimates differ because the more pieces that the tape is split into, splitting it into multiple line charges and smaller pieces, the more data points we will have to calculate the charge of the tape, and the measurement will become more precise as we take more data points and split it into smaller and smaller pieces. And kind of in line with that, as the tape is broken into smaller and smaller pieces, there's less estimation involved in the calculation of the charge on the tape, and therefore less error due to the estimation. Thank you for listening to my video on Physics 2212 Lab 2 line charges.